5, 4, 3, 2. Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Mend. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of housekeeping notes to review with everyone. First of all, we are recording our session today. So if you miss any of our discussion, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we'll be sure to send you the recording via email as soon as we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. The first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're tuning in from today. I'm already seeing that we've got a global audience, so welcome from everywhere. If you have any specific questions, we do want you to send those in to our Q&A tab on the right side of that chat section. Just helps us keep track and to do our best to answer as many of your questions as we can today. So be sure to send them in as you think of them, and we'll do our best to address them. Additionally, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in chats, questions, and to fill out our post-webinar survey. There's a link in the handouts, but I'll be posting the link in the chat toward the end of our session today as well. So our topic today is quick wins for EKS container security. I'm joined today by Ariel Schuper, VP of Product at Mend.io. And he's also called in reinforcements with James Ferguson, Principal Solution Architect at AWS. So Ariel and James, thank you both so much for joining us today on Techstrong Learning. Ariel, do you want to dive us into things?
Absolutely. Thank you, Cody, and good morning, James.
Good morning.
Thank you. And let's talk about quick wins for container security. So before we start, let's talk about the current status, what's common today in container security, and what quick wins we can make it more. Quick wins we need or we can do in order to make it a little bit more effective. I'll hand it over to you, James. I'll kick it off and take us through the container security ecosystem.
Yeah, thank you, Ariel. Right, currently today, Gartner estimates that 95% of global organizations will be running containerized applications in production by 2028. We've definitely seen this movement at AWS, and you as customers and engineers, developers, et cetera, have also seen that uptick quite a bit over the last several years. Currently today, in fact, we've got close to 10,000 customers, anywhere from companies such as Salesforce, Adobe, Snap, and many, many others who use containerized applications and loads with services such as ECS, EKS, and Fargate. So excited to talk about this today with you and Mint. Pleasure to be here.
That's amazing. Let me ask you just a quick question, like from your experience. Is it fair to say today that people creating their cloud native applications are doing it on containerized infrastructure?
Yeah, I would say that the bulk of customers have moved to a native solution with containers in today's world. We saw a large migration from VMs in the past, over the last several years, but we've actually seen a lot of customers and companies moving to more of a native application and solution on top of containers. And so today, I'd say roughly 75% of our customers run natively on containers, and probably 25% are still doing migrations.
Wow, so amazing. And what's your take on Kubernetes? Do you see the same uptake on Kubernetes, or you see kind of something which is a little bit more widespread on different distributions, different options? You mentioned ECS, for example.
Yeah, it sort of depends on the customer and the engineers' skill sets within the organizations. Depending on how fluid they are in container application, either security or application development. Using something like EKS might be fairly simple. Using something like Fargate, where we manage most of the infrastructure for you, might be simpler for companies who are just starting in the space. So between those three, services, you definitely see a wide mix depending on where they are in their process.
Amazing. Sounds great. So let's talk about the foundation of container security.
Yeah, thank you. So, on this slide, there's 6 things that we at AWS feel are security foundations really for an organization, developers, engineers, security professionals, et cetera, to kind of think of and think through. Those are adopting a multi-account structure, and why is that important? Not only from a sort of a blast radius perspective, multi-tenant perspective, but also thinking through things like, security for specific types of applications, PII, compliance regimes, NIST, ISO 27001, et cetera. Breaking those out properly is definitely important. Implementing the principle of least privilege, that's a given, I think, especially with security professionals, meaning do not scope your policies, your access, your roles any greater than they should be. You want to have those tightly knit to only the things that they need to do. Things like zero trust frameworks and approaches along those lines certainly come to mind here. Automate tasks to save time and reduce risk. Again, shifting left with your code base, using things like Mint services and others to help sort of automate that process so that your developer isn't on sort of manually checking their own security credentials, and then you have a long kind of onerous QA cycle. So making sure that you mechanize as much as possible, so it makes it easier for your customers, your engineers, your developers, et cetera, to get to production faster, knowing that you have security and the best practices in mind. Establishing a centralized logging account, again, very important. We refer to this as like an audit account at AWS, and untouched logs, so that for a fact that you've got both your audit logs, your application logs, et cetera, centralized to that bucket, and then using that with things like your SIEM and other tools that you have at your disposal, whether that's Splunk, using things like Athena with QuickSight on our side, or things like OpenSearch, et cetera, to do advanced searches across those logs, stitch them together, validate your concerns, do root cause analysis, et cetera. Protect data in transit and at rest. Again, EAS 256 encryption, I think at a minimum, is required here. Things like TLS certs, MTLS, et cetera, definitely a must. And then apply security at all layers, meaning not just your execution, but your identities, your pod security, your infrastructure security, et cetera. So definitely those security foundations are things we recommend to most customers. And we have some really good documentation around this as well on our GitHub repo. So definitely worth taking a look at.
That's absolutely true. I tested it myself. But James, I want to kind of touch base on something which is super interesting, and I'll play with it in the past. I'll be happy to hear your thoughts about. You mentioned, implementing, the principle of least privileges. In Kubernetes, in containers, it's slightly complex, with service account and role-based access control. And I saw this recent announcements from AWS about, mapping IAM roles to service accounts that can really simplify it. Can you a little bit elaborate about it? That sounds like super exciting functionality.
Yeah, great question, and thank you for bringing that up. We launched something called pod security. I think a lot of our customers in the past have had some struggles in terms of if you're doing blue-green deployments or you're changing your clusters quite frequently, adding those identities all the time in policies to those clusters because it becomes a little bit operational overhead for your teams, definitions, et cetera. And so adding pod security allowed you to sort of scope that out, do multi-account security across pods and service meshes. So you no longer have to sort of think about every time I deploy a cluster, is it going to have the right role, the right policy attached to it? As long as that pod is attached to those clusters that you've launched, it will automatically have those policies attached to it. So it's kind of a many-to-one, operation instead of a one-to-one operation in the past. So definitely a big plus. We have some great documentation on that as well if you're interested.
Amazing. Perfect. Sounds great. So I really certainly appreciate it as someone who's tried to play with it in the past. Let's talk about, the specific challenges in containers.
Yeah. And this slide, again, these are probably challenges that you as an organization or you as an engineer, developers, or even, security teams deal with yourselves directly all the time. And so just wanted to kind of call these out. Some of those are scale, to my comment earlier about pod security and multi-account security. How do you scale your clusters, your nodes, et cetera, to a point where you can communicate multi-account or even multi-organizations with those containers. You do it in a way that's prevalent and secure, and makes it work for you. So scalability, definitely one of the security challenges that you see a lot of. And so that's why you saw things like the pod security, announcement we made at reInvent. Short-lived, containers. What does that mean in terms of, TTL, 30 minutes? We have customers who do thousands a day of entire pods or, clusters, short-lived. How do you manage that at scale? Different types of containers, insecure sources, upstream, downstream sources. Again, that came out with Log4j a couple of years back. I'm sure many of us remember that painfully. And again, using frameworks like Salsa or in Toto, things like that help with those controls around, dependencies with upstream and downstream, security implications for sources. Definitely a must. Lack of resources, that's a given in the security space. I think I was reading this morning that there's a 100-to-1 ratio today of security professionals to engineers and developers, which is really untenable. And so again, creating mechanisms around security, drivers for your organization, definitely a must in a world where, security professionals are hard to find. Network configuration, again, this is probably the biggest one in terms of challenges for customers. DNS, there's that famous term that says it's always DNS, we also say it's always network, and so making sure your network configurations are properly done and scoped properly for what they need to do. And then lack of visibility into what's going on within, your clusters, your nodes. Why did things fail? Did we run out of memory? Why did we run out of memory, et cetera? So those are security challenges we see across the board for a lot of our customers. Definitely worth, kind of taking these, 7, items here on the slide and expanding on that, a little bit more.
Absolutely, and we'll do so. You mentioned, Log4j, which we all remember, a very painful experience. We're going to touch it a little bit later in our presentation, so I'm preparing the audience. But James, I want to ask you just quickly from your experience, working with all those, huge amount of customers, where do you see people spend most of their time on? What is the biggest effort, or where they keep hammering you about, what's going, that they struggle in?
Yeah, I think I think the biggest thing that you'd see on here is probably your scale and lack of resources and visibility. Those three things. The others, I think are sort of given based on the application flow, what you're trying to accomplish, et cetera. But those three are probably the biggest questions we get. Lack of visibility, again, around logging. I'm stitching those logs together. Currently today, a typical security organization might have anywhere from 150 to 250 schema types of security logs, flattening those out. So launching things like OCSF, which we did, a couple of years back here at AWS, provides a schema that, flattens that out for your infrastructure and your logs, so that you have one sort of schema, and you can use an ETL process with that with our security lake. And that makes it much faster to find anomalies, problems across your logs, instead of constantly changing, ever-changing schemas that you might get from either third-party, first-party data centers, other cloud providers, et cetera. So, definitely one of the biggest call-outs typically with most of our customers.
Wow, that's really interesting. So let's talk about how we make life better.
Yeah, so when we have a thing here at AWS called Raise the Bar. In fact, in every interview process, we usually have a bar raiser, and that's an individual who's there to sort of ensure that We're always raising the bar in terms of who we hire, how we hire, et cetera. We use the same thing with our services. And so that's why we use raise the bar on your container security posture. So two things that we call out here is integrate AWS security services to achieve continuous threat detection. Things like Guard Duty, Macy, et cetera, are all part of that. CloudTrail, CloudWatch, making sure that you're able to see what's going on inside your clusters and nodes at every moment. And then the second one is empower your DevSecOps teams to unify visibility and automate those responses to help them achieve operational excellence in cloud security. And you do that with partners such as Mint that we're on the call today with, as well as our additional services that we provide that stitch those logs together for you in real time, provide the power to your DevSecOps teams and your SecOps teams to find and mitigate issues before they happen, when they happen, and after they happen. So really excited for this discussion. And I think the next section here, Ariel, is over to you.
After it?
Yep.
I
jumped ahead of myself.
We'll take it in a minute.
Yeah, and so lastly, container image issues. Again, I have this saying. It's called continuous service improvement, or CSI. Something that I've preached about, for the last probably 10 years at least. Doing cloud security and development, whether it was at AWS or prior. But breaking it down into the simplest of its imperatives. So detect, investigate, remediate. Those are probably your biggest sort of transitional continuous service improvement approaches for containers. So again, detection is key. Making sure that you have the right visibility, you have the right logging tools. You're able to see at a moment's notice what's happening, when it's happening. Investigation, definitely key. So again, having the right kinds of SIM tools, having the right types of log stitch, together, schematics, et cetera. And then lastly, remediating those concerns either automatically in kind of reactive or proactive engagements, whether that's, having the right tools in place to help your teams, or to help, again, with that remediation post, something happening, doing blue-green deployments, facilitating, your playbooks, moving the cluster that's a problem out of your production and replacing it with one that's hardened images, et cetera, and containers, and then ensuring that your team have the ability to investigate, what actually happened with those. So again, those three items definitely key to success for security professionals and our customers.
Perfect. Thank you, James. And I'll try to now to talk a little about some quick wins, we can make it a little bit more efficient, because this is definitely a great foundation. And I think, you outline all the right pillars, everything should be done. But I want to, with the audience, kind of jump into details, walk a little bit down, and try to examine, how like the common day or the challenge our security team facing. So if I'll try to summarize what I see from my experience working, with customers in large scale environments, is that in container security are often ineffective. Why are they ineffective? I think, to me at least, and I be happy to hear your thoughts about it. Users get a lot of workloads alert. There's you mentioned tons of workloads. You have customers doing like thousands of deployments a day. And those, workloads keep a gap, getting scanned, getting a lot of alerts. They reach the situation that we call like alert fatigue, meaning the problem is we have too many alerts and we don't know what to focus about. So it's super common to see, get alerts. You have a critical vulnerability in your application. You have a vulnerable application which is public facing. You have a vulnerable container which is, has high privileges. Now, the amount of open source uses containers is significant. A lot of it's like being reused, taking a lot of, base images or downloading a lot of, packages or layers, across the network. And the amount of alerts which you get consequently is super high. And we have a lot of alerts, and you have very few people, as you mentioned, in a ratio of maybe 1 to 100. Then this one person needs to face, 100 different microservices, getting the accumulated amount of alerts, all this aggregated amount, and he needs to do what to do fast. Now, in order for him to be efficient, this security team will need to bombard it with tons of alerts, need for every alert to check, is it a real risk? Is it something that, we need to remove? Who needs to remove it? Okay, who is responsible? If we have someone person, who is identified, who can be the person I need to call to? I need to point out that he needs to go and change, and how fast I can remove it, and what we can do in the meantime. Those are probably the daily questions the security team asks themselves. But when you multiply it by the amount of microservices, containers, workloads, amount of alerts which are getting, this is something which become almost impossible to handle in the classical approach. And let's talk, about some few quick wins that we want to chat about and to introduce and see how we can make it a little bit more efficient. If I look at the first one, and to me, this is something which is really critical. Today, in a situation where we have alert fatigue, and we get to multiple alerts per every microservice that we deploy in the cloud, it's super important to understand what is the real risk. What CVE is a CVE that an attacker can exploit, and what CVEs exist in the code, but since it's a code which is not running while the container is running, it's not CV that can be exploited. It's a CV that is there in the code, but the code is not relevant, is not code, is not being used. If I can know and I can tell in advance, before you go to deployment, what are the real risks and what are not, this is something that can really save me significant amount of potential risk. Now, you mentioned, James, before the log4j, which was kind of a huge call out, and everybody was kind of running around trying to find where they have log4j, how they can replace it, who can replace it. But sometimes, what we found out was a lot of times, you had kind of a log4j in your code, but it was not something that is being used, is being called, it was not a function that can be used, and therefore the importance of fixing, removing it is going down, or at least into a lower scale or lower severity than the classical one. Let me show you like a quick example, of what we are saying. So I'll share my screen in a minute. Okay. I'll share screen. Okay, and I hope everyone can see my screen now. Right. And if you can see here on the bottom of my screen, let me just. Okay, you can see my screen now. And what I want to do is I want to scan a classical image. I took an example of HTTPD, a classical Apache server. I downloaded a tag, I ran it in locally on my machine. And let's look at the result, for example. Just a minute. All right. Okay. I have some authentication issues. We'll touch it in a minute. Let me fix it in a minute. Move to the next slide, and then go back to my demo. But in essence, what I want to show you is how a simple scan can bring you out all the vulnerabilities. But if you tune the scan and you're looking for those reachable vulnerabilities, you can really get like a significant amount of reduced or reduction in your CVEs, and really focus on those CVEs which are on the exploit path, those CVEs that an attacker can attack. Let me just try to fix in my authentication for a second, and then I can just a second, and then I can go back and show this demo. Right. Perfect. Let's go back until I'm logging in. Let's take a look at another example. We talked about quick wins. Okay, we talked about quick wins, how we can, identify risk owners. So when we have a crisis, in the cloud, when we found something which is really critical, something that really bother, we get a call from security. when they define something is really, something need to alert their users about, then they want to define who's the owner, who's the developer. Now, when I'm in the cloud, I want to know who's the developer who wrote this, this code. One of I think, the best practices that we discovered is that if we can track down to find the exact specific developer who's responsible for it, it will be very easy for us to open a ticket, create a PR, or just even create like, an issue for those developers in whatever, paradigm that they prefer, in order for them to get it, fixed as soon as possible. Now, one of the quick, tactic for that is to use the Docker file. If we can find all the developers, if we can, create a metadata that is used in the Docker file, and we can, follow this Docker file into our deployment, we can easily find, who the developers are and which repo this something came up, and then we can, create for them the issue in the best place, help them to fine tune it or to find it and fix it, in the shortest time possible. I call it, we can really reduce the mean time to repair, the MTTR metrics, significantly. And let me show you another example for that. So hopefully this time, no authentication will be easier to show it. So let's take a look at some quick win that we can do in this regard. Right. Okay. So hopefully, can you see my screen? So don't get panicked. This is just a simple Docker file for the same HTTPD container image and on the show. And what we do, for example, in Mend is when you scan your images or when we scan your files, we add few labels. We add labels that tell you what is the path, so it'll be easier for us to find where exactly it came from. So what is, the source, which repo, it can be identified, when we scan your repo, when we scan, your pipeline, we know to insert those labels into the Docker file. And this is something that allow us afterwards when we're looking at the scan. And for example, this is, the same HTTPD image that I scanned. It allowed me to find what is the image ID, what is the SHA, allow me to find what repository it came from, where did I find, these sources, so I know the source of truth. And it's very easy for me now to go back and track the developers who committed to this repo and open for them a ticket. It could be open an we can automatically open the issue in the repo. We can create a Jira ticket if they prefer, to keep the repo in a different format. So this is something that, it's a small win, allow you, to get it and track it and very quickly find your users. So this is another quick win, that we can use when we go to when we're trying to help security teams identify, users and help them fixing security issues. Something that can reduce our time to remediation or time for remedy and improve our metrics. I want to touch about the last item. And the last time is how to balance risk and complexity. We all know that security teams are really focused heavily on risk. They want to know what is the vulnerable item, what is the best security fix, what is the least vulnerable image or the least vulnerable container image which I can use, what is perhaps the least exploitable. Today, there's a lot of information about not just about CVE and vulnerability, but there's a lot of information about exploitability, meaning how is there an exploit for this CVE? How mature is this exploit? How probable is this exploit to be used, depending on like different pen testing tools. So there's a lot of information around security and around risk. But I want to also highlight some information which is not related to risk, related to recommendation. If I want to go to developers and tell them, hey folks, I want you to fix these items, developers don't really care about the security. They care about how complex it's going to be. Is it going to break my build? Is it going to break my image? Do I need to spend hours to find which API was changed in this upgrade of this library and to, work it around? And for them, it will be much better to understand what is the fixed adoption rate. Meaning, how many people adopted this, this fix to this, version before me? What is the test passing rate, that of this package that, was done before? What is the merge confidence that I have that, that I would know that the merge will not going to make any break into my existing builds? And again, like something like release age will be kind of a useful information for us to consider. And in this regard, I want to touch another. I want to share my screen again, and just to highlight, free open source tool, that anyone can use. So I want to share with you this bot. It's called Renovate Bot. Renovate Bot also has as well like GitHub application, but in essence, this is a dependency management tool. Everyone can use it. It's free to use, free download, and the beauty of it is that it doesn't just help you to upgrade, but it gives you a lot of valuable information. It takes the packages and the dependencies, really give you valuable information for you to consider when you're planning whether or not you want to upgrade it. And as I mentioned, it highlights issues like what is the merge confidence, what is the age, what is the test pass ratio. So you can really play with it. You can really check, and it's something which is, when you look at those with this information, you consider how to upgrade or how to change, package, or what package should change to. This is something which is, again, super useful, help you, the security professional, to go to developers, convince them to make this fix, because I'm sure when you come to developers, they have other items they need to work on, they have other work on their schedule. And, in order for them to get them, to make a quick, fix or remediate things quickly in their, cloud deployment, in their production deployment, issues like the merge confidence, the test passing rate, the code coverage of those tests, those elements are super beneficial for them. And if you want to be like super advanced and you want to look at the OpenSSF scorecard to understand how security is maintained, it's another great attribute to consider. But any of those operational items, you can see can really, make your discussion with engineers, much more efficient. They can really appreciate it and use it, in order to get those fixes that you want as a security guy quicker in your production time. So those are like 3 quick wins that everyone can implement and can change fairly quickly. And if I want to summarize, what are the items that we want for you guys to remember is that, first, container programs, main challenge is at the heavy load. There's a lot of alerts. You need to sort out what you need to work with. Most of the alerts stem from code owned by developers. And if you focus on 3 items, you can really make your container security program much more efficient. Focus on alerts which matter, accurate identification of who's the owner that they need to fix it, and offer him not just telling us just what the risk is, but also offer him suggestion that can make his life easier, can make this fix much better. So if you remember that, I believe you can make your container security much more efficient. I'll turn it over, James, to hear what your thoughts about it.
Yeah, no, this is great. I think overall, what you provide as a partner of AWS and as a security organization is fantastic way to give more audibility, visibility for developers and services and teams to see what's happening and help mitigate that right away. Again, getting back to that continual service improvement, which is key really to a lot of what we do here. And I'm curious, Ariel, just from you mentioned in here, like most alerts stem from code owned by developers. Could you expand more on that, like a little bit, in terms of, is that I bring in code myself that I'm using on my personal laptop, that I've gotten maybe from, Stack Overflow or something perhaps, or I, got an answer from something off Google, and perhaps I haven't fully vetted it. Yeah, I'm just curious.
So I think, James, today the variety of sources really becoming much higher. If in the past
Yeah.
just download, a Docker, you look at like a Docker Hub, you look for the best, image, the most popular, the most deployed. Today, you just mentioned it. You can get, different sources that help you to, compose your code. Now, all the research that we did and all other research that I see from other sources show us that even the generated code is still vulnerable. They're still using common packages. Today, I think the paradigm for adding code is what can be popular, what can solve your issues, and not so much about security. And consequently, we see a lot of security alerts which coming in from self-generated code. Now the issue with that is, okay, now I have vulnerabilities, but I have many of them. I need to find those which are relevant, and I'm just trying to fix my authentication issues. But what I want to show that sometimes even the most severe risk is not accessible. You cannot hit it. I mean, there's no point. I mean, of course, it's always best practice to be updated and get the latest and also be on the base. But this is more for like technical debt. From security perspective, many of those high-profile CVEs are not always relevant. But to the contrary, what I also want to show that sometimes that is super high-profile known CVE, but something in like an essence, like a big essence of your, of your code, which is really, in when you're running in containers in use, even if it's not like a high or critical, but it's a medium, but it's really easy to exploit it. This is something which you should be aware of. And that's why I think, we need to change we need to make like a small shift from looking at what is the severity and what is the score at what's the impact on me. Am I impacted with it? Am I developers really need to stop his sprint at time? Okay, stop. You need to fix it. Or this is something that I have some grace. I can wait. I can have some time. I can, schedule it in a more convenient manner. This is a paradigm shift that I think, we need to make in an industry in order to make the container security scanning, more efficient and more effective.
Yeah. Yeah, that's great. Yeah, I mean, all of that is super important. I think, to the point, somebody mentioned earlier too, in one of the comments in the thread here on chat, around Salsa and Toto. Do you feel like, those kind of frameworks, for downstream, upstream dependencies, kind of helping the open source communities manage, who's giving code when and how and where? Besides it being super important, are you seeing a big drive for that from your end as well?
So absolutely. So supply chain is something that is really becoming, hot topic recently. We see more and more attacks coming from supply chain, which is, you downloaded something which looked legitimate code. I think you downloaded the latest package, and then you discover that someone change switch. There is tons of item like that, in the media every quite frequently. And I think this is something which is really critical because I think, James, you also mentioned in your slides, when we track what exactly passes, not just what type of code, but how is it being built, what are the sources which are built, is something that can really improve later. I think we can talk also about adding some signing. So we can sign, we can verify that the same code we had in the repo was the same code which is used, when you build your image, which is the same code which is then next deployed. Again, we talked about how we deploy, how we track, from the cloud to the code, who's the owner. But the same thing apply on the other side around, from the code all the way to the cloud, to make sure that nothing changed. It's the same, today there are so many tools that can make it so easy. And can make it so easy to use. And I think it's not like such a very common attack, but there are such an easy tricks that you can add, and you can completely eliminate this attack vector.
Yeah, absolutely. That's a great comment. I mean, TPM 2.0 supports for that, hashes, et cetera. Definitely a key to that pipeline security. To your point, absolutely.
Perfect. Any more questions from the audience?
Yeah, so we do actually have quite a few questions still, so let's just take them from the top, guys. And I'll also put them on screen just so we can read along. So Geeta asks, what are the proactive approaches one should take to avoid security challenges?
Yeah, I can start that one, Ariel, if you want to jump in second. I think proactive approaches, again, gets back to some of the keys that we talked through today. One is, static code analysis, as you're writing your containers, et cetera, making sure that, how you write those, what's happening, what your dependencies are, et cetera. Everything that goes into those containers, is checked and validated. That's one side. I think the second side is operationally, once you've moved those into a cluster, or a node and you're running in production, making sure that not only operationally from a control plane perspective, meaning the definitions of those containers, nodes, pods, et cetera, is secured, but also the service mesh, how you secure that with MTLS, mutual TLS, kind of that zero trust approach, your identities, et cetera, things are locked down properly. And so that's definitely key to making sure that, you're avoiding those security challenges up front, and ensuring that you have an owner of those security challenges. I think, making sure that developers are part of that security team is key. So scaling factors here come into play in terms of, security shouldn't be the only one concerned about security. You should have a culture of security, day zero type mentality across your entire organization. A lot of people always see security as a voice of no, but it should be a voice of, we're doing this the right way from day one, and a voice of yes, meaning how do we make this a reality? How do we make these things quicker, faster, easier for everyone to participate, but also everyone is part of that security, cognizance of what you're doing as an organization. So definitely key to building a better practice for your company.
I agree with that. And now I'll just chime in for one more comment that I said. I think proactively making sure you know which alerts and which risk are real risk and which I'm just like, alerts that are there, but, not impose a significant risk on you. This is, I think, the critical question, that you need to answer on top of what James just mentioned.
Great, thank you both. James kind of touched a little bit on this next question, so let's go ahead and pop it up. Who ultimately is responsible for security implementation, and what are some good ways to divide up that responsibility?
Yeah, Ariel, do you want to start that and I can jump in?
Sure. Yeah. Well, I think, it's everyone's responsibility. I think that's the answer in short. It is true that, security teams are the one who need to be responsible for identifying and finding those issues that matter, is not the one who need to find and trigger the process. But at the end of the day, security team don't fix, code. If you have a flaw in your code, if you didn't configure it properly, they don't want to get into it. They're not sure exactly what are the items that you need to do, if this is really, left like this on purpose or not, if this library is a must, if it's really easy to change it. So this is why it's their responsibility, to identify and focus. But the developer at the end, they're the one who need to pick up and need to kind of complement and, again, create an updated version, push an updated version to the code, and make it address this need.
Yeah, I think I answered a little bit of that in the chat, but yeah, I mean, definitely agree. It's both. Security, I think their job is that is their primary job is security. So they're going to come up with the tooling. Maybe they're going to come up with the implementation of how things should be done. In terms of controls, frameworks, et cetera, to follow. But really, the developers are the ones at the ground floor doing the work. Needing to use those tools and speed that process up, but also ensure the security of what they're doing is reasonable. And so, making sure that they, both work as a team hand in hand, security setting kind of the expectations and the approaches, developers also helping be the security cognizance of what they're doing from a developer standpoint. To Ariel's earlier slide there at the end was, most of the alerts are coming from, code from developers. And so, it sounds maybe as a given, but again, if they're part of that security approach from day one together as a team, I think you've got, a good path forward.
Perfect. So I'm seeing a few more questions here still. In your experience, what remediation steps were taken for prod security issues?
Okay. So
Ariel, you want to? Yeah, go ahead.
So I'll try. So from our experience, when you have something in prod, let's say, I'm deploying now and I found a critical vulnerability in a public facing, container. Now, the quick check is make sure it's public facing, but sometimes it is. I need to access it. It has to be like my front end. It has to kind of be accessed from the outside. Then, what I need to do. I have a critical vulnerability. Let's say, James talked about like log4j, for example. I cannot leave it like that. I can put maybe a firewall, I can put a WAF rule for a certain period of time, but at the end of the day, I can't leave it like this. And then the quick remediation step is, as soon as I can, to get an updated version. And when time permits, and I have the next, upgrade, the next change. And James touched it that, usually containers are ephemeral. They're not there for ages. They're there for, let's say, deployments are usually, some people do it every day. Some people do it a few times a day. Some people do it like once a week or once in a few weeks when they update. But whenever it's possible to have it ready and to make this, upgrade and change, and then I can eliminate this risk. This is a simple, it's a quick win. It's a simple thing that you can do fairly easy and doesn't change or break or anything which above your classical maintenance day. Sometimes if there's something which is much more dramatic, yes, you do need, to break your maintenance day and to do something different. That's correct. I hope I answer it. Okay.
All right. Well, Ariel, we've got a follow-up for you. How do you prioritize alerts? What are some best practices?
Perfect. So if it's okay, Cody, I want to again try to share my screen. I managed to make the authentication, and I want to give you an example of what I mean by prioritizing. So let me try to share my screen. I apologize, people. I'm dragging you again, but I hope it's going to be worth it. Okay. I want to give you an example, and I spoke a little bit about scanning HTTPD as an Apache server, which is a classical thing. So what I did here is I ran this, classical scan, and you can see the results here, on my screen. Okay, let's take a quick look at the results. Yes, you can see it's a lot. I'm gonna flip all the way up. I try to make it large. Don't get scared. Okay, so this is a classical HTTPD image downloaded from Docker Hub, running on my laptop, and you can see there are 256 vulnerabilities, 1 critical, 22 high, 76 medium, 154 low. And if you really take a look, you can look at it more deeply for the demo purposes. You can see that some of it is, as James mentioned, the log4j. Now, I want to give you an example. I want to do the same trick, but look at it from like a different scan perspective. Let me show you something interesting. Let me just quickly go to my downloads environment and go in my downloads. I want to go to all right, and here I want to. All right, just a minute. Okay, I'm going to scan the same exact HTTPD. Hope you can see my screen, but take a look at the results this time. Okay, this time I added another engine which tried to identify what are the vulnerabilities, which one of them is reachable, and which one of them isn't reachable. Okay, just a minute. All right. Okay, so I still have my PD. All right, I still have my. Okay, I still have my issues. So I didn't solve the login, but again, this can really help you to find out if this vulnerability has an access from the code, someone is going to be executing or not. If you have this capability, you have this way to sort it out. So instead of 256, you end up with 20, with 24, something like this. So the really, really, small amount of CVs, and this is why it really helps you to focus on what are the things they need to do and how can I, really make it much more efficient. So I apologize again. I'm sorry. Still have some issues that I need to work with in my authentication. But whoever wants, ping me afterwards and I'll show you. And again, it's super simple, easy to use. Everyone can use it. And it's really help you to get better prioritization or better, at least, analysis of what are the items that you need to focus on. I'm sorry again for that.
Oh, not a worry at all. So it looks like we're down to our last question here from Nadia, and I believe Nadia is referring to slide 10. So let's just jump back there. In this slide, what do we have under secrets?
Okay, so secret is a big issue, and secrets is an item that you need to keep looking. In this example, for example, it's easy to find secrets in your code, in environment variables, in your Docker file. But the scan for secrets doesn't stop there. The same for secrets Kubernetes expand, into, using your config map and using, all different configuration files that you have. And I think, in this case, AWS did an amazing job in really identifying secrets, which are being used, which are active, which can be used. I even got sometimes alert about it. James, maybe you can add a little bit more about it. I think secrets is like a whole world by itself.
Yeah, we've done a lot of work with secrets, especially with our secrets manager, system. A lot of customers, probably many of you who are listening to this, use HashiCorp Vault. We've released an API where we work together with HashiCorp Vault so that you can continue to use Vault directly with Secrets Manager on AWS. Vault continues to be your primary source of truth for the secrets. But you can do a one-way sync, for example, into Secrets Manager. You can use those at scale directly in your pod security for accessing secrets and certs that you're using for, kind of fingerprinting in between applications and your service meshes. So, those kind of approaches definitely are key, but you'll see a continued approach from AWS to work with our partners and continue to push, these integrations where, you as a customer or a developer might use something other than AWS or first-party, third-party data centers where you need to support more than just what AWS offers. And so, seeing that, kind of continue to evolve is definitely key for you as a customer and as a developer. But secrets definitely is key for most of our organizations to authenticate and encrypt, what's happening for, those service meshes. So developers can't see that information, but it's still secured. And it's not released, in a way that compromises security on your end.
All right, gentlemen, it looks like we have time for one more question, and then we're going to bring things home. So let's go ahead and place it on screen. Having a dedicated developer who focuses more on code security than on developing new features is a smart move to protect against cyber threats. What do you think about this?
So obviously, I think no one wants to put, developers just to focus on security. You pay developers because, you want them to focus on your business logic. But having said that, you still need to maintain security. Now, I haven't seen this, developer who knows all the code of all the different microservices and can fix everyone's code by himself. I do think that, this is something that's going to take you down the road. I think the best way is to kind of distribute the work, distribute the load between your teams. For team who wrote the code, it could be, if you do it correctly, it could be super short, super quick kind of maintenance, which they do anyway. It's always like a good technical practice to keep you updated, and they're doing it regularly anyway. And you just like do some little bit of a tuning and get it to that. Taking a dedicated developer, in my opinion, is not the most productive thing to do.
Yeah, I would agree with that. I think that's why you have SecOps, security operations teams and DevSecOps, where they're focused on those specific tasks to sort of help your developers, and then keeping your developers focused on getting those new features and helping business impact. You need both working hand in hand together. Certainly, developers have a key role to play in security, so I don't want to take that away, but having both hand in hand is key to success.
All right, guys. Well, with that, we are out of questions and are nearing the top of the hour. So I do just want to thank the both of you for joining us today on Techstrong Learning. It's been such a pleasure learning from you and speaking with you before we went live today.
Thank you so much, Cody.
Thank you very much, Cody.
Of course. So before I release our audience, a couple of final notes. Today's session was recorded and we'll be sending it to you via email here shortly, but you can also find it living on the Cloud Native Now website. That's cloudnativenow.com/webinars. We will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you so much for all of your questions and all of your chats today. If you'd still like to become eligible, feel free to submit that post-webinar survey. It is both in the handouts as well as pinned to the top of the chat. I'd like to thank Min for sponsoring our program today, and to everyone here, thank you so much for spending time with us. We appreciate you, and we hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thank you again, James and Ariel.